Hello, everyone. Today we will be talking about cheap multimeters and whether or not they are safe to use. This is a basic current clamp meter made by the Chinese company Aneng ST170. It's quite a decent meter. I like it, but it only costs $6, and of course, designed by Aneng, which is a Chinese company, and you know how the Chinese are when it comes to electrical safety. Not very good. So let's examine the insides of this and see how safe it is. First of all, in order to get this thing out, I have to remove the batteries because this battery compartment is extremely strangely designed. One, two, come on, there you go. Popped out like a soda can. Now I can remove the back cover. I have already removed the 3 screws holding this in place. Boom. So here are the 2 input jacks. This is the volts, ohms, and resistance. Whatever this is. I mean, it just measures capacitance and resistance and voltage, and probably something else that I'm forgetting about. And this is the common ground. And here, there are no fuses in this multimeter because it doesn't measure current through the input jacks, it measures current through the clamp, and that doesn't require a fuse. But it would still be nice to have a fuse here, I guess. The only sort of input protection that I can see is this little green ball right here, which is a PTC thermistor, which acts, I guess, as a resettable fuse. So if, for example, the control circuitry or something else out here shorted or it carbon tracked and created a short circuit, this little PTC thermistor will will be able to stop the current or at least significantly slow it before anything crazy happens like an arc flash. Although I'm not really sure if there's anyone out there poking Aneng meters into 400 volt 3-phase stuff, or even 200 volt 3-phase stuff. If you are, get a better meter.
Hi, I'm at the computer today because there is something that I completely forgot to show. So this right here is a screenshot from a video by EEV blog showing the comparing a expensive Fluke to a cheaper but still quite expensive Bryman multimeter. And this is a pretty decent example of what a good multimeter should look like. So first of all, here are the input jacks. They are quite a bit different than the ones found in the cheap multimeter, but that isn't really that different. First of all, look at this absolutely massive fuse. Whew, even more massive than the 6-7 meme. This is a 1000 volt fuse, which looks like it's giant compared to a normal fuse, and it looks like it's filled with sand, which will help prevent arcs forming. You got a nice big current shunt in here, but that wouldn't be used in a clamp meter. There are plenty of what appear to be metal oxide varistors over here, which will clamp over voltage spikes on the voltage side, and there are also these little things in heat shrink, which I guess could also be metal oxide varistors. Those will help keep the voltage between the voltage input and ground to a low enough level that the multimeter won't complain about it. And it would be so nice if the generous Chinese manufacturers decided to put all these amazing features into the little Aneng, but you know the Chinese, they're not going to do that. So let's continue with the video.
It doesn't have to be a Fluke. It can be something cheaper, but just don't settle for the Chinese tat. But cheap multimeters like this are still perfectly fine for low voltage work. Like if you're just using this to help probe around a computer to see if their voltages are correct, that's perfectly fine because these meters are still perfectly fine for low voltage. Anyway, that is about it for my little speech on multimeter safety.